Hey everyone, we're going to look at number 2 in section 3.2. We're going to use the definition of the derivative, and this is really the limit definition of the derivative. We're going to use that limit definition to find the derivative of the function f of x equals 5x squared plus 8. Remember, the derivative of the function f of x can also just be written as f prime of x. So it could just say find f prime of x if f of x is 5x squared plus 8. Now, some of you already know the derivative rules, like the power rule, the sum rule, the constant multiple rule, and you know how to find the derivative of any polynomial real quick, okay? However, this says use the limit definition, so you can't just use those shortcut derivative rules. You can certainly check, so some of you already know right off the bat how to find this derivative real easy, but until we get there, we have to still use the limit definition to understand where it comes from. So what is the limit definition? Here it is. F prime of x is the limit as h goes to 0, f of x plus h minus f of x over h, right? This will be given to you on the test. There's, of course, the there's this definition. There's also the alternate definition, but we're going to use this one. And so I plug f of x plus h is simply replace x with x plus h. So I have 5 times x plus h quantity squared plus 8. So there's f of x plus h minus f of x. Well, that's just 5x squared plus 8. Be careful to put that in parentheses so that I distribute that negative sign through. Okay, and it's all over h. If I plug in h equals 0, I get 0 over 0. So I've got work to do to simplify this. Of course, I'm going to expand x plus h squared, and I hope you understand that that's x squared plus 2xh plus h squared. It's not just x squared plus h squared, right? Remember, x plus h squared is x plus h times x plus h. You have to FOIL that out. Okay, now we're going to distribute 5 through, so be careful. We multiply each of these terms by 5. I get 5x squared plus 10xh plus 5h squared. Distributing that negative sign, well, the plus 8, don't forget that. Distributing the negative sign gives me those, right? Changes the sign of those, still all over h. But now we can do some simplifying, right? So I've got 5x squared minus 5x squared, so those are gone. I've got 8 minus 8, those are gone, and I'm just left with 10xh plus 5h squared. Now, again, if I plug in h equals 0, this is still of the form 0 over 0, so I can't determine the limit yet, but notice I have a common factor of h as we expected to get. I can factor that out, and then I can divide numerator and denominator by h, and I'm left with this expression, which I can plug in directly, h equals 0, and this becomes 10x plus 0, or 10x, and that's the derivative. So again, some of you know the shortcut formulas and know how to go right from this to that. And that's fine. You have a way of checking, but on a test, when I ask you to use the limit definition, this is what I'm expecting to see. You have to show the algebra step by step. Notice you keep the limit sign there every time after the equal sign until, of course, you plug in, right? Do the direct substitution here, and then it's gone. But make sure you show correct support, algebraically correct support on these. Okay, so there is the limit definition of the derivative for this function.